Hey guys, let's talk about the next problem. It's a very easy one, right? It says write two vectors of the same magnitude. Now, two vectors can be different in two parameters. One is that their magnitude should be different, of course, and if the directions are different. So what decides that the direction of the two vectors is different? Look at this. I have two vectors here. That is the vector u, which is -2, 1, and 2, which are the direction ratios. And the direction ratios of this vector, which is the green vector here, is 1, 2, and 2. So now see, their direction ratios are different, so their directions are different. But I can see that the magnitude is same. So what decides two different types of vectors? It can be the magnitude and the direction. So what decides the magnitude? The length of the vector. Right now the length of the vector is same in both the cases. What's different is the direction ratios. So if you can just write two different sets of direction ratios which gives you the same magnitude, your problem is done. That's exactly what it's doing here, right? So I can see that the direction ratios of this guy is -2, 1, and 2, and the direction ratio of the other guy is nothing but 1, 2, 2. So guys, mathematically, how do you do that? I know that the direction ratios are given by this one. So the modulus of vector, let's say u here in this case, is nothing but the root of -2 squared plus 1 squared plus 2 squared. So if you solve this, you get a 4 plus 1 plus 4. The square root of that is nothing but 3, which is exactly what you have here. Now, like that, what are the how do you find the magnitude of vector v? Vector v is again given by the root of 1 squared plus 2 squared plus 2 squared is again root of 9, which is 3. So that makes sense, guys. How can I write two vectors? I just need to have this combination which gives rise to the same answer 3 here now. So what is the condition, guys? If you have another set of direction ratios with another vector, I think we can have the same magnitude and another vector with another direction, right? That's what exactly we need here, right? So how do I do that as a question? Look at this. If I can move this guy in such a way that I have its direction ratio as 2 and 2 and 2, but I'm very sure that its magnitude is not the same now, right? Look at that. This magnitude is different. There is 3.46 and there is 3. Why? Because you have a 2 and a 2 and a 2. Here you have a 2 and a 1 and a 2. So can you have another 1 here somehow? So if I have to pull out the z coordinate and make it as 1, so look at this, what's happening. I'm just pulling it down and I can see it is 1 now. Now what are the direction ratios of this guy? 2 is 2, 2, 1. But I can see that its length is again 3. So overall, to write two different vectors of the same magnitude, what you have to do is this, guys. It's pretty simple. You can actually have infinite vectors like that. But the idea is this. If for all the direction ratios have 2 and 1 and 2, all right, these are set basically. I can write 2i plus j plus 2k. So this guy will have the same magnitude. Modulus of vector a will be 3 for sure. Now, if you have another vector b, and let's say I change this to -2i plus j plus 2k, again the modulus of vector b would be the same thing, which will be 3. You just have to do one thing. You need to have these numbers 2, 1, and 2. That's it. You have a negative and a positive sign, doesn't matter. So now you have a vector c again, which can be written as -2i, -j, and -2k. Again, you can see the modulus of this guy will be nothing but root of 9, which is 3 itself. So overall, how can I write two vectors with same magnitude? Just make sure that their direction ratios have the same values, all right? They can interchange. You may have it like 2 and 1 and 2, or you can also have another vector, let's say vector d here, which can be written as I plus 2j minus 2k. But I see that 1 and 2 will come here. The only idea is these numbers should be there. Their combination doesn't matter. So that's how we write two vectors with the same magnitude and of course with different directions.